Geometry lesson 24, algebraic proofs. In your textbook, this is starting on page 151. This is, for us, I think, kind of the beginning portion of proofs, so this stuff is still staying fairly simple. It's not, at this point, nearly as difficult as some of the stuff that you see in Algebra 3 with trying to prove triangles or something like that. This is all still, when we say algebraic proofs, we're just proving equations. And so the first thing that we look at is we're going to look at what a proof is. It's an argument where we're using logic to show that a conclusion is true. Algebraically, we are writing down our individual steps with the definition or explanation for what that step actually is. It's my justification for how I get to an answer. Okay, it's the things that we've been saying verbally up to this point. Now we're going to start writing down. So whenever we say, hey, I'm going to add this to both sides, what we're going to write down is we're going to write down the addition property of equality. Whenever I say, hey, I'm going to subtract this from both sides, subtraction property of equality, you begin to get the gist, right? Okay, so that's all that's really taking place here. An algebraic proof uses properties of equality to solve an equation. These properties are listed here below and should be things that we're fairly familiar with. Okay, like we started off with, addition property of equality, adding the same thing to both sides. Subtraction property of equality, subtracting the same thing from both sides. Multiplication property of equality, multiplying both sides by the same thing. Division property of equality, dividing both sides by the same thing. Symmetric property of equality. Here's where we get into a little bit of a different deal. Symmetric property of equality, if I get something like 12 equals x, proofs really don't like a number to equal a variable. They want a variable to equal a number, so they want that variable on the left-hand side, which is just a simple step of flipping it, and that flip is called the symmetric property of equality. So one that you might want to be familiar with that you can use. Okay. Reflexive property of equality. My Algebra 3 people should be familiar with this. Basically, if something is equal to itself, it's reflexive. Okay? Transitive property of equality. We've dealt with this a couple of times up until now. We've talked about the transitive property in terms of the law of syllogism, right? Symmetric property of equality, if A equals B and B equals C, then A equals C. Okay? That's the transitive property. Substitution property of equality allows me to sub something in if it is equal. So if A equals B, then B can be substituted for any A in any expression. We see this whenever we're trying to solve equations where we know, let's say y equals 4x plus 3, and I've got another equation, right, where it's 5x plus 4y equals 7. Well, I can sub in that whole first equation because y equals that equation, and I can solve for x. Okay, we do that. That's kind of an Algebra 2 question, but many of you have had that. So, all right, any questions up to here? Okay, that's a handy chart to have to refer back to. An algebraic proof shows step by step how a problem is solved. It's your justification for how you got to your answer. So a lot of the stuff that we do in our heads, where we solve equations really quickly, the only thing that we're doing here is that we're breaking it down. We're showing all the steps. We're justifying each step. Don't make it more complicated than it needs to be. Okay, it doesn't have to be hard. Okay, but each step has to be justified with one of the properties that we saw. Okay, and of course, the more that you learn, the more properties that you know, the more things that you can solve, the more justification that you can give. Okay, if a step required adding a number to both sides, addition property of equality. Whenever a step requires that you perform basic mathematical operations on just one side of the equation, basically what we're talking about there is if I have to basically, I might use the distributive property of equality to solve one hand. Okay, one side. But if it's something else, we are allowed to say simplify. So you wouldn't use the word simplify if I was using the distributive property, but in a lot of cases I can just simplify. Okay, if I'm not using a property of equality where I'm doing it across both sides, I'm allowed to simplify. Okay. Most proofs begin by presenting the facts of a problem. The first line restates what you've already been told, okay? And that reason is given, okay? Because it was given to me, I don't have to give a property for it. I know it because I was told that, okay? Those are the facts of the case as they stand right now, okay? All right. And this is setting us up for what is a two-column proof, okay? And it doesn't necessarily go into this, but how we want to set these up is we want to have our statement, which is the math that is being worked out, will be worked out over here step by step by step. And my reasons will go on the right correspondingly over here. These are my properties, these are my theorems, those are my justifications there. Okay? So those of you that haven't run into this yet need to familiarize yourself with that table. Okay, a two-column proof. All right, let's see if we can find some questions in here. Let's see. I think the first one really... Okay, yeah, let's start with number 1. 16x equals 2x minus 4, then 2x minus 4 equals 16. This goes back to that chart that you had on the first slide. What property is being used there? Go ahead. C, symmetric property, right? All we did was flip it. Okay, good. All right. Let's see. This is talking about congruency statement. Let's see where number 2 falls in on things. 25, so we don't have to worry about number 2. We'll look at 3, 4, and 5. Okay, 3, 4, and 5. Given this diagram, that measure angle JKL is 100 degrees. So they're telling me all of this is 100 degrees. Stephanie solves for the value of x, fill in the missing justification. Okay, so they start off with measure angle JKL. Okay, JKL equals measure angle JKM plus measure angle MKL. Okay, do we have a justification for that? What do we call that? And what I don't like about this is that you can't jump to given here. Okay, usually that would be the first thing, but they don't actually, all they're really stating there is that measure angle JKL equals 100 degrees. So if we were going to have a given, that would be it. Okay, this would be like lesson 2 or 3 is going to be your answer to this, would be in lesson 2 or 3 of your book. We covered this. Measure angle JKL is made up of JKM plus MKL. Can anybody tell me what that is? You think A? You think it's the transitive property? So if A equals B and B equals C, then A equals C? Are any of those things said to be, do you have multiple things equal to each other there? No, so it's not the transitive property. What am I working with? What are those things? What's that? Okay, I've got addition, but what are those things? Are they segments? They're angles. They're angles, and I'm adding them. Right? So, okay. But let's not say B, because the answer isn't B. I need to know what the actual property is. What is the property that's being used? Anybody tell me the name of the property? There we go. Angle addition property. Okay. Now, from there, they substituted in 100 for measure angle JKL. We were told that. We can do that. Then they substituted in 6x plus 8 for JKM. They substituted in 2x minus 4 for MKL. Substitution, not a problem. All they did, because we're just working with the right-hand side, we're not moving anything across, they combined like terms. They took 6x plus 2x to get 8x. They took 8 plus negative 4 to get 4. All that is simplifying because it stayed on the right-hand side. Okay? There's no property of equality there. Okay? Then they subtracted 4 from 100. Because I subtracted 4 on both sides, it's the subtraction property of equality. Are we following the proof as it's shown? Okay. So from here, from 8x equals 96 to 12 equals x, what did I do from this step to that step? Divide. All right. How do I state that as a property? Good. Division property of equality. Okay? And then, because we don't like 12 equals x, we flip it through symmetric property of equality. Okay? If you get a proof on a test, it's probably going to look like that. It's going to be a fill-in-the-blank type of thing. Okay? But you have to know your properties. You can't just guess at it. Okay? You need to know what they look like. You need to be able to follow the steps down through here. All right, let's look at another one. Okay, 4. Okay, same type of thing. Solve the equation. This one I think is fairly simple. Okay, 4x minus 6 equals 34. Fill the missing justifications. I start with my given. What is the next thing? Chandler, can you tell me what we're doing from step 1 to step 2? Okay, yes, but let's state it. Okay, addition, property of equality. Good. All right. Then notice they just simplified. They added 34 plus 6 and got 40. Okay, it's nothing there. All right. From here, Marcos, what do they do from here to there as a property?
Oh,
4x equals 40. How do I get from here to here? They divide. Okay, so state it. Division property of equality. Okay, I'm far less concerned with you being able to find an answer in a multiple choice set as I am you knowing how to do it. Okay, because you're, my people that are in Algebra 3, do you guys get multiple choice options to pick from when you have to write proofs? No, you have to write the whole thing, right? You got to know what the step is, and you have to know what the justification is. Okay, so here we're finally getting to a point where you guys that are in Algebra 3 are taking a big step backwards in this class, right? You've already learned some of this, and it's easier than what you've had to do. Okay, all right, let's look at this word problem in terms of a proof. Mrs. Tibbs has 26 feet of fencing to build a rectangular play area for a rabbit. She wants to have the largest play area possible, but it can be no more than 8 feet long. To find the width of the play area, she uses a formula. Perimeter equals 2 times the length plus 2 times the width, where P is the perimeter, length is the L is the length, and W is the width of the rectangle. Fill in the missing justifications. I really don't even need all of that information because I'm just following the order of events, right? Okay, we've got our given equation, right? What is happening here, Michael? Good. Good. Substitution property of equality. Okay, we substituted in 26 for our perimeter. We knew our length was going to be 8. We don't know what our width is going to be. Okay, she's only got 26 feet of fencing. All right, we see that she simplified. She multiplied 2 times 8 to get 16. It was only done on one side of the equation, so all I had to do was say that it was simplification. Okay, she subtracted 16 from 26. Okay, subtraction property of equality. She went ahead and she shows that subtraction by saying simplify 10 equals 2W. Jordan, with 10 equals 2W, what did she do to solve for W? Divided. So how do I state that? Good. Division property of equality. Okay, we go ahead and we simplify that. 2W divided by 2 is just W. 10 divided by 2 is 5. right? Symmetric property of equality because we want our variable on the left-hand side. Okay? Are these seeming doable, easier as we go? Okay. Let's see. All right, so this one gives me a problem, but does not have a proof for me to just substitute in and fill out, right? So I'm going to actually have to write a proof. We got our statement, we got our reason. The area of a rectangular photograph is 84 square inches. The photograph's length is 2x plus 2 inches, and the photograph's width is 7x inches. Hold on. Okay. Let's see. Find the dimensions of the photograph, provide a justification for each step. I'm going to try to do this the best I can because I don't have an answer key in front of me. All right, so we could state some givens. You know, area equals 84 inches squared, right? Given. Okay. Length equals 2x plus 2 inches given. Width equals 7x inches given, right? Okay, we could probably go ahead and set up a formula, right? Let's see, we would get 84, or well, let's see, our formula, area equals length times width, correct? Okay, I'm going to say definition of area of a rectangle. Does that work? Okay. Next thing I'm going to do is I'm going to say 84 equals 2x plus 2 times 7x. What's my justification there? How do I get from here to there? Substitution. Okay, substitution property of equality. What's next? Well, because I'm not multiplying on both sides, right? It's just simplification, right? Because I'm going to go ahead and I'm going to multiply 7x times 2x plus 2. So I'm going to write, what, 14x squared plus 14x, right? Okay, that's just simplify. Because it's only happening on one side. Okay, what would we do after that? I would want to subtract 84. This is where this question actually gets more complicated because it looks like we're dealing with a quadratic. But let's go ahead and let's subtract. Actually, I'm trying to think if we can divide all of this by the same thing. Does 84 divide by 14? So what it says in the answer key?
14x squared plus 14x divided by 14 equals 84 by 14. It equals 6.
All right, so let's divide everything by 14. Right, that's going to end up being division property of equality because I'm dividing everything by the same thing. Okay, so 84 divided by 4, or sorry, 84 divided by 14 is 6. So I get 6 equals x squared plus x, right? And that's just simplify, right? Okay, what I'm going to do from here is I'm actually going to jump over to this hand side. Okay, actually, let's put this here. And I'm going to kind of erase some of this back a little bit. Okay, after I've got x squared plus x equals 6, what would you do? Subtract what? 6. Okay, so let's see. We're getting x squared plus x minus 6. Okay, so subtraction property of equality. Okay, subtraction property. Now what are you going to do? What's that?
X squared plus X plus 6 equals 0. Then use brackets.
Okay, so we're saying x, x. This is a 1, so we're looking at things that multiply to be -6 but add up to 1. So it would be what, 2 and 3? All right, so +3, -2. I'm going to say we're factoring here. I don't know if I skipped a step there. But our answers would be x plus 3 equals 0, and x minus 2 equals 0. We're continuing to simplify here, so x equals -3 or x equals 2. Okay, but can it be -3? No, because we're talking about width. Okay. So I might have kind of fallen apart there at the end, but that's our basic premise on how we would go through something like that. Okay? Take it one step at a time. Don't get too overwhelmed with it. If you need help, get a hold of me. Okay? All right, we'll take a look at it. We'll do our best. All right, does that give us enough to kind of go on for now? There are more questions like this in here. Trying to see. You've got maybe something a little simpler in number 10, where you can see where you would simplify on the left-hand side by getting 5x minus 10, right? Then you're using properties of equality, solving it down for x, okay? All right. And the rest of these are congruency statements, so I really think number 10 is probably about, number 10 and 11 are about your last ones, and I don't think either one of them is as hard as number 9 was. Okay, so we're going to stop there, and that way I can help you guys out if you need it.